Today on Applied Science, I'm going to talk about using brand new CNC technology to repair and upgrade old CNC technology. So I've got this 1982 Bridgeport CNC milling machine, and I've been using it for about a decade, and to its credit, it's been working pretty much fine the whole time at 4800 baud being run from a DOS program on my laptop. And even though it's still working, it's quite slow, and I can't really do 3D contouring with it because it just can't process enough G-code commands. And also it's had a couple of small problems, and I'm worried it's going to die soon. This is the original 1982 circuit board here. Anyway, the motors are in great shape, so I'm going to keep those, and the upgrade kit that I bought will work just fine with them, but it needs to be the encoders that actually tell the machine or tell the control where the axes are need to be upgraded. So let's take a closer look at one of the drive motors, and I'll explain what we're doing today. This machine uses 3 identical DC servo motors, and so we happen to be looking at the x-axis here, and most of the magnets in this motor are actually in this region here. This smaller magnet is a tachometer output. So besides the plus and minus for the motor, it also has plus and minus DC output voltage for tachometer. However, modern controls don't use that, and so what we're going to do is make an adapter so that I can put a modern high-resolution encoder on the back of this motor here. So originally, the original system actually used both. So it had not only the tachometer output, but it also had this fairly large setup like this. And inside this metal can, there was a fairly low resolution shaft encoder. It was about 200 counts per revolution. Maybe I'll tear one of these down actually, because it is fairly interesting how it was built. But anyway, the modern shaft encoder is only this big, and it's 2,000 lines per count, and it of course goes much faster and is solid state, and everything about it is pretty much better. So what we have to do is make an adapter to put this back on and then mount the new shaft encoder on there, and then I think what I'll do is just gut this metal can and put it back on there, and then reuse the connector here, which is a really strong, robust, oil resistant connector, and I'll just solder new wires onto it but use the existing strain relief. So I thought about this for a while, trying to figure out the easiest way to mount this tiny little shaft encoder onto here and also have it be protected by the original metal. And what I came up with was to use this piece and put a flat piece of metal that will sit down inside this flanged area, so that when I put it on here, there will be a flat plate that I can mount this other shaft encoder onto, and then I'll be able to build up that whole metal box that you saw before. So the trick is I need a round metal plate that will fit down into this flange, maybe even be attached by these 4 screws, and then also have a spot for the shaft to come through and some mounting holes for this. But unfortunately my CNC machine is down, so I can't use it to make the plate. So let's head over to the bench and I'll show you what I'm going to use. This is a handheld CNC router made by a company called Shaper. It's currently in beta testing, and it is really cool. Let me just show you what it does. I have it configured to not plunge the tool into the work. It's just going to hover above just to show you what it does. So I'm going to start a cut, and I'm looking at the screen here and it's telling me where to drive. However, if my hands shake around a little bit, you can see what the thing does. It uses its motors to compensate for my hand movement. So if you want to cut a straight line, it'll tell you to drive along in a straight line as best you can. But if you can't do it, or if you're struggling to keep up, the machine will use its motors to help you out. So I'm following the directions on the screen here, and I'm tracing out a circle. And again, if my hands shake a little bit like this, you can see how it's compensating. Here's a view of the screen so you can see what the operator sees in that little demo I just showed you. So I'm going to position the machine over the start of the cut, and I'm going to press the green button here. And if this were actually doing a real cut, it would have plunged the tool down into the work. And so it's giving a cue here to go in this direction. So if we start driving, you can see that the machine is showing where the cutter is going. And if we move around like this, like handshake, you can see that and hear it probably, that the machine is moving around that cutter. So let's say we want to stop here and start again, we can just press the red button and it'll lift the cutter out of the work, and we can go back and maybe start somewhere else or cut something else. I'm going to zoom out, and so you can see the whole workspace here. So let's start from the beginning. I'll show you how I made this part, starting with CAD and then going all the way through to the cut part. One of the really interesting features about this tool is that you don't have to use a computer in order to start cutting. So for example, if you just want a plain circle and you know what diameter you want, you can say place and then shapes and then just tell it you want a circle. And what you do is you actually use the position of the machine itself as a mouse. So if I click, it just put a center point there, and then if I swing out, I can change the size of that circle. So keep in mind that this is a beta machine and they're adding lots and lots of features so that you can do better entry here. But I really like the idea that you can just choose to make any size circle you want, and you can even see it's reading off the diameter here, so you can kind of very, very carefully dial it in and then click again and it will leave that circle there, and then you can cut that out. So pretty cool. I mean, just that alone, anyone who has like a set of hole saws for cutting holes in wood is going to like this, because you can have any size hole you want. But anyway, for today's project, I did the layout in SolidWorks because I'm so familiar with it, and then saved that as a DXF and imported into Inkscape, and then added some colors. The colors tell the shaper cutter, the CNC router, which holes should be cut on the inside and which holes should be cut on the outside. So since I'm going to be cutting out this little plate from a sheet of aluminum, I want to cut the holes out on the inside and then cut the whole round circle out on the outside, and that's what the colors mean. And then I just saved it as an SVG file on a thumb drive and plugged the thumb drive into the router. Let's talk about the workspace setup. The machine uses this special optical tape to figure out its location in space. And since we're going to be cutting through all the way through this 16th inch aluminum sheet, I don't want to cut into my workbench, so I put down some particle board, and there's no specific position for this tape. I just randomly put 4 strips across. And the idea is that I'm going to position the aluminum plate here, and then when the machine is here and I'm driving along, the machine's camera is kind of facing out in this direction, so it can see all of those markers. And as long as this is very securely taped down to the spoil board, it won't move relative to this. And then the machine's cutter won't move relative to the markers because it's using a camera to see that, and everything will be fine. For larger projects, what you can do is put this optical tape right on your stock. Like, let's say you're cutting through plywood, and then just drive along with the machine like that, and you can cut right through the tape. As long as the machine can see enough markers, it's okay. So I'm going to use Nitto P95 double stick tape and put some on this surface of the aluminum and then flip it and stick it down to the spoil board. Okay, we've got the plate mounted here, and just as a reference, this is a plastic part that I made earlier just to make sure everything was going to work out. And you can see that the 4 inner holes for mounting the small encoder are going to be threaded. And so I don't have the right drill to mount into this. So what I'm going to do is just spot drill them and then drill and tap them later. Even just having the spot drills, these have to be fairly precisely positioned because that little encoder doesn't have a lot of slop in there. So even just getting spot drills in the right spots are a big help. So what I'm going to do is take the router out of the machine and load in this little spot drill here. The next thing to do is to use the machine's camera to scan the entire space so that it knows what markers are available and also where the stock is now that we've got it double stick taped down to the spoil board. So I'm going to press the scan feature, and then I'm actually going to pick the router up off the table and turn it around a bit. And you can see that the markers are turning green, which is good. That means that it's identified them. And then also I can see the edge of the stock. So the camera has a very wide angle view, and you can see that you can see the edge of the stock there with all the markers in view. So I'm going to press the green button to have it store that scene. So it's stored the location of all the markers. And then I can tap to change the zoom level. So this is zoomed way in, and you can see that we're looking at reflection in the stock there. And then if I tap, we've zoomed out a little bit, and you can see here's the edge of the stock. And if I tap again, you can see a much wider field of view. So the way this works is that with the stock empty like this, what we're going to do is use the place feature and drop a shape down onto the stock. So for example, we'll go to the USB drive, and then encoder plate is the thing that I just created in SolidWorks and Inkscape. So we'll select that, and then I'm going to zoom out, and now as we move the machine around, you can see that we're moving this outline of the part. Here's a clearer view of the screen. So you can see as we move this thing around, it's actually moving the parts placement on the stock. And when we get this where we want it, I don't want to waste too much stock, so I think I'll probably put one kind of right about there. Hit the green button, and it automatically zooms in and is ready to start cutting, as you can see. But before we get started, I'm going to place 2 more of these on the stock. So instead of start cutting, I'm going to go back to place, and then the USB drive, and place another one of these. So now you can see we've got 2 of them, and I'll put one next to, I think I'll zoom out again just so I can see it. I'll have another one over here, and I'm not ready to start cutting. I'm going to place another one. So conveniently, this piece of stock has room to do 3 of these across the top. Okay, so now we're going to set the machine up to use that spot drill that I loaded in. So the holes that we're going to spot drill are about 0.83 inches in diameter. So I'm going to enter 0.83 so that the machine thinks it has a tool of that diameter and it will be able to plunge through that hole. And another cool feature of this machine is that it will automatically detect how long the tools are. So I'm going to press touch off, and what it's doing is it's actually driving down into the work without the router spinning, and as soon as it senses that it hits something, it's very, very gentle, then it knows that's how long the tool is. So it's automatically calculated the tool offset relative to the part surface. And then we'll tell it the cut depth is going to be pretty small, just about 20 thou. This way, when we come across one of these holes, it knows, or it thinks the tool diameter is small enough to go down into that hole, so it's going to do a cut. And you can see start cutting just lit up there. So let's do one. So what I'm going to do is start the router up, and then you probably won't be able to hear me. And all I'm going to do is press the green button. It's going to plunge down and make that spot drill, and then I'm going to press the red button and it's going to come back up. So let's see what we get. Okay, so there's the nicely laid out spot drills. Now I'm going to switch over to an 1/8 inch end mill, and then we can cut out the other drill holes, the inner hole, and then the outer dimension. Okay, now that I've loaded the 1/8 inch end mill, I'm going to tell the machine that we're using an 1/8 inch diameter cutter, and then it's going to do the touch off routine again. So it just drove the head of the cutter down into the work without it spinning, of course. And then we're going to change the cut depth to about 80 thou. So the work is a 1/16 thick, or about 62 thou, and then 80 means we'll have 20 thou into the spoil board. So we'll zoom out again, and I think what I'm going to do next is cut these holes first. So this is actually larger than 1/8 of an inch. So what I'm going to do is start the router up, press the green button, and then instead of driving around, what I'm going to do is hold down the green button for auto mode. And since this toolpath fits entirely within the machine's envelope, it can actually helix down in there and make a really nice hole. So all I'm going to do is hold the machine still and let it helix down in there and clean that hole out. So let's do that. Okay, so there we got those 4 outer holes in. So these outer holes are what hold the thing to the machine, and the inner holes are what hold the encoder. So next we'll do the center hole, and then right after that, for each one we can just do the outside and cut them all out. Okay, so we got 3 done, well, almost done parts. We'll take the those spot drills and drill those out next. But as you can see, pretty good. I should point out that this tool was designed for woodworking, and the folks at Shaper have been very nice in allowing and even encouraging me to try things that are sort of outside its intended use. So cutting 1/16 inch thick aluminum plate seems to be fully within its capability. I was using an 1/8 inch carbide end mill, and the one problem that I was having is that when the end mill would plunge, it would have sort of a cap of aluminum stuck on there. So I was using some WD-40 to try to prevent the aluminum chip from sticking to the cutter, but it was still a problem. But anyway, that's kind of more of a cutter problem, not a Shaper problem. Anyway, in future videos, I will be talking about this thing a bit more and even using it for woodworking. Okay, see you next time. Bye.